Hi everybody, my name is Ajay Singh and today we would be taking a look at the second Physics Nobel Prize, uh, the theme of it, and we would be looking at who got those. So in our previous video we had talked about the first Nobel Prize, which was awarded in 1901. So this Nobel Prize was awarded in 1902 to Lorentz and Zeeman. So it was jointly awarded, and we would also understand why they got this jointly. Peter Zeeman in 1896 was studying how light was affected by magnetic field. So he was using various kind of lamps, sodium lamps, mercury lamps, and applying the magnetic field to it and studying the impact onto their spectral lines. Without any influence of magnetic field, it was a single spectral line. But with magnetic field, he experienced those lines were getting splitted into multiple, and that is today known as Zeeman effect. And the explanation was provided by his mentor, Hendrik Lorentz, and he had given a theory in 1892, which is known as electron theory, and he was his mentor in the same university. So he presented his electron theory and mentioned that the atoms have electrons which can conduct electricity, and their oscillations give rise to the light. They emit the electromagnetic waves. uh, so this was the first electron-based model of atoms, and this theory was enough to explain the observations by Zeeman, and we call that Zeeman effect. So Lorentz assumed that light is emitted by oscillating charged particles, and it's Lorentz force only, which is essentially force on the charged particle when it moves with a certain velocity in a magnetic field. Because of this additional force, it alters the oscillation, and hence different frequencies were getting generated. So this explanation was nice enough to consider him for Nobel Prize along with Zeeman. So essentially Zeeman gave the experimental evidence. However, the proof was given by his mentor Lorentz. Right, so let's understand this further. So this is the high energy state, and this is a lower energy state within the atom. And when the electron transitions from higher to lower energy state, it emits light, and which was having a single frequency, and this was a spectrum for that. So under no magnetic field, this was the observation. However, when the magnetic field was applied, there was different kind of oscillations in Lorentz language, and because of that, these atoms got different frequencies of oscillation, and because of these additional energy states within the atom, Zeeman observed these additional spectrum lines, right? And this was under magnetic field. Let's see very briefly what was the setup. So under the influence of magnetic field, you can assume this as a lamp, and kind of a vapor lamp, and could be from sodium or cadmium or mercury, and North Pole, South Pole. So this is the magnet, and under the influence of magnet, whatever light was emitted was passed through a spectrometer, and when passed through the spectrometer, it was observed that the spectral lines were getting splitted. You got a sense what was happening over there. Yeah, after this we had J.J. Thomson, and then we got the Bohr model as well. Their combined work had significantly advanced the understanding of relationship between electricity, magnetism, and light. It has played a key role in understanding of energy levels, angular momentum of electrons in atoms as well. With this, we'll close for today, and for next session on Nobel Prize in Physics, stay tuned. Thank you very much for your attention.